Era Software Tutorials. Digitizing Methods, Part 2. In this video, the second part of the tutorial on digitizing methods, we will explore the tools for digitizing objects using pixel-based artwork images. We have created a new blank design. We will use the same workspace layout we previously used, with document map and smart design views, and we will keep circular arcs as the curve type. We will explore a digitizing method called auto trace. In vector images, the contours of shapes are already defined in the objects that make up the image. When we create our embroidery objects from a vector image, we use those same contours, without the need to digitize them. In pixel-based images or raster images, there are no contours, but only regions of different colors. To create our embroidery objects, we need to digitize those regions. We can do it manually, visually following their edges, or we can use auto trace to recognize the contours of the regions in an automated way. Although auto trace also works with vector images, it is much more useful with raster images. The tool works much better with images with well-defined edges and an acceptable resolution, at least about 200 dpi. Let's select one of the sample images using catalogs, for example, like this one. Let's start by adjusting its size. Let's define the vertical size to be about 120 millimeters.
Now let's use the Align menu and center the image in the design.
We don't need to adjust anything else on the image, so we will lock it to avoid selecting it while we are digitizing. Let's create an embroidery object for this region of the image. It has a very irregular shape and there is a hole in it, so we will use a uniform area object. So, we will select the uniform area tool with pattern stitches. We will use the default pattern and set the basic properties. When we start any of the object creation tools, the first geometric element to digitize will be the main contour. Once the main contour is defined, we can digitize the holes, add direction lines, etc. As we have already started the tool, the system is waiting for us to digitize the main contour. The default digitizing mode is manual, so we will change it to auto trace. Auto trace works as follows. When we click on a point in the image, the tool gets the color at that point and starts scanning the image following a horizontal line from left to right. This process continues until it finds an edge, that is, a significant color difference with respect to the color of the point where we clicked. It then marks that point as the start point and begins to navigate the image along that edge, keeping track of the path it is following. It stops when it returns to the marked starting point. Immediately, it presents a preview of the contour it has detected. Due to the way it works, the tool may detect different contours, depending on the point where we made the click. By clicking here, it detects a contour that we will use as the main contour of our object. But by clicking here, it detects another contour. In a moment, we will use this contour to digitize the whole of our area. Let's click here again and accept the contour as the main contour. To do this, we just need to start capturing another element, such as the direction or the hole. So, we open the context menu, right-click, and select Hole. The system will complete the creation of the main contour and enters into the capture of the hole. Let's use auto trace, and this time we click on this point so that the tool recognizes the region that corresponds to the hole in our area. Again, we will use the Tool tab this time. Let's select another element, the direction line. The system completes the creation of the hole and enters into the direction definition. We just need 2 clicks to define it. This time, we will skip the definition of the entry and exit points. Don't worry, we will see this topic in a moment. Then, we press Enter, or select Accept from the context menu, and the system generates the stitches for our object. This is the very basics of auto trace. So, let's create another new design and try with another image to explore the tool further. We will select an image that allows us to use auto trace with turning areas. Using the Rescale command, we will adjust the size so that these segments become about 7 mm width. Then, we center the image and assign some transparency using the Object Inspector to improve the visibility for our embroidery objects. Finally, we lock the image. Let's select our colors. We will use some colors from the default palette, but we will arrange them. We drag this color to the position 2, and this one to position 3. We can do this at any time. There is no need to do it before starting to create the objects. We will start with this region. Select turning area with zigzag. Check density, 5 lines per millimeter will be fine. Again, in order to be able to see the stitches generated for the objects more clearly, we will omit the underlay layer. Remember that, in almost all cases, we must set an underlay on our objects to get a quality result. We change the digitizing method to auto trace and capture the main counter. Then, select direction and define some directions for our turning area. We complete the object by selecting Accept from the context menu. Let's look at this area of the object. As the length on each side of the curve is quite different, the stitches tend to accumulate on the shorter side. The accumulation of stitches is, in general, an undesirable effect, as it can cause problems such as thread breakage. Let's create the following object, which has a similar curve, but let's set a compensation property called short stitches. The property has 3 compensation levels. We will use level 2. We capture the main contour and one by one the directions. We finish the creation by pressing the Enter key. The short stitches compensation caused the appearance of stitches that, instead of extending from side to side of the contorn, are shorter. This avoids the accumulation of stitches that we observed in the previous object and are visually imperceptible in the embroidery. Let's continue with the letter T. A shape like this would usually be digitized using 2 objects so that the stitches in this region are vertical and the stitches in this region are horizontal. However, we can digitize it with only one object, using auto trace and a geometric element that we have not yet mentioned, cut lines. We capture the main outline. And then select cut line. The cut line nodes are always on the contour. By moving the mouse, the system moves them over it. We place a node here. And another one here. The cut line divides the contour in these 2 virtual contours. We add the directions for each of them. The system will generate the stitches almost as if they were 2 different objects. Let's continue with the letter S. We capture the contorn, the direction lines, And we finish by pressing Enter. We repeat the process with the letter I. This region of the image, the letter H, presents a situation similar to that of the letter T. Here we should use 2 cut lines to divide the contorn into 3 contours, one for each vertical region and one for the horizontal region. However, we will use a more automated auto trace mode, called Auto Complete. Select Auto Complete and click to capture the contour. Note that the definition of geometric elements is disabled in this mode. Press Enter and the system will complete the creation of the object. Click on Edit Object to take a look to the object created with this tool. The system added cut lines to divide the contorn and directions for each of the segments. To keep the style we have been using, let's edit this direction. Let's continue using autocomplete to digitize this letter T. Click to capture and press Enter. The next region, the letter O, presents a new challenge. The shape has a hole in it. For this type of shape, we would normally use a uniform area, but we cannot use turning stitches on these object type. We will use a turning area and a cut line to digitize this shape easily. Select turning area with zigzag and auto trace as digitizing method. We capture the main contour by clicking here. Select hole and capture the contorn of the hole by clicking here. Select direction and add directions one by one. In this area, instead of placing a direction, we will place a cut line. But we will press and hold down the Shift key. Note that the visual appearance of the cut line node is different if we hold down the Shift key. It is yellow and violet instead of just violet. This means that the cut line will function as a cut line and as a direction line at the same time. Let's press Enter and check the object. Our object is working as if it has a contorn similar to the letter C, but that continues to finish at the same pair of nodes where it started. Let's also see that the stitches, at both sides of the cut line, follow the direction defined by the cut line. Let's delete this object and recreate it using autocomplete. Select turning area with zigzag and autocomplete. Click to capture. As we can see, unlike auto trace, autocomplete captures all the contours of the region, and not just one of them. Select Accept in the context menu and check the object. Autocomplete added a cut line and direction lines, as expected. However, it added direction lines at each side of the cut line to get a result similar to the cut line and direction combination we used before. Let's continue with the letters U and T using autocomplete. Click to capture and press Enter for the U. And the same for the T. Let's adjust the directions on the letter U to keep the style we have been using. Select Edit Object, click on the U. Delete this direction. Adjust this one. Add one here. And here. Let's open a simulation view and see how our design looks like. Let's pay attention to the threads that connect our objects. Let's use the Reprocess All command, opening the options of this icon in the bar at the top edge of the application. We can also press Ctrl key and F9, that is the shortcut for this command. The system recalculates the stitches of all objects, and the connections between them are updated according to the configuration of their entry and exit points. When digitizing our objects, we always omitted the definition of the position of the entry and exit points. By not defining them, the system set the default value, close point, that is controlled by the system to make the connection between the objects as short as possible. If we select any of the objects and look inside the More tab of the Object Inspector, we will see that both the entry and exit points are set to close point. If we move any object and reprocess, we will see that the positions of the entry and exit points are updated following the close point rule. Once the embroidery is finished, the threads of the long connections are usually removed and those of the short connections are left behind. If our embroidery machine has thread trimmers, it is possible to set up automatic thread trimming for thread lengths over a certain size. For example, if we move this object here, the connection becomes longer. But if we move it a little further away, the connection disappears because of this automatic trim. Although trims cause an increase in the embroidery time of the design, if we want to avoid cleaning up the connections, we can force trims at the end of each object. Select one of the objects, and from the Tool tab or from the Object Inspector, and set the trim property to Yes. As we can see, the simulation view is updated and no longer shows the connection. Let's repeat for this other object. If our machine does not have thread trimmers and we want to remove the threads from all connections, it may be more difficult to do if the threads are very short. We can relocate the entry and exit points so that the connections are longer. Select the object. The exit point is indicated with a red triangle, and we relocate it. Sometimes the entry and exit points are close to other nodes. To select them easily, hold down the Alt key. The mouse pointer changes shape to indicate that clicking will select the exit point. We will also move the entry point of the next object. Now the connection is longer and can be removed manually more easily. Once we manipulate the entry or exit points, the system no longer controls them. In the Object Inspector they appear as user-defined. We can set them back to close point if necessary. Let's continue with the other regions of our artwork. Let's use the Measure tool and check the widths of this black region. Click and drag to measure. We see that its width is between 2 and 3 millimeters. We can use a turning area with zigzag to digitize it. Turning area with zigzag, and we will digitize using autocomplete. Select the needle. Click to recognize all the contours and press Enter. The system creates the outline and adds the necessary cut lines and directions. Repeat for this object. And for this last one. We will use an uniform area for the remaining regions. Select the needle. Uniform area with pattern from the Smart Design. And choose a pattern like this. We will continue using autocomplete. Click to recognize and create an object for this region and press Enter. Repeat for this one. Remember that autocomplete recognizes all contours. We don't need to worry about the whole. And finally this last one. If we review our design, we notice that we made a mistake in the sequence we followed to create the objects. We should have digitized the uniform areas of the scissors body first and then the edges. This is the usual way to do it since we get a much better finish. Let's adjust the sequence using the document map. Select the first object area pattern, hold down the Control key and select the others. Then click on any of the selected elements and drag. The blue cursor shows the position to which the objects will be moved when we release the mouse button. We place them just below the last area zigzag object. OK. We have moved the objects within the design sequence. As we can see, the gray objects will now be stitched after the light teal objects. As a last step, we will set thread trims for all objects. The Edit Object command is already active, so we will click and drag to define a selection rectangle that includes all objects. For many of the properties, such as trims, the Object Inspector allows us to make changes not only on a single object, but also on sets of objects. So, from the More tab inside the Object Inspector, we activate the trim and set it to Yes. This change applies to all selected objects. We have completed a more complex design using automated capture tools. In the third part of this tutorial, we will create a design by manually digitizing all our embroidery objects. Thank you for watching.